So for chapter 8, question 4, it says, two vehicles are approaching the intersection. One is a 2,500 kilogram pickup truck and it's traveling at 14.0 meters per second from east to west. So it's going from east to west at 14 meters per second, and that was 2,500 kilograms. Okay, and the second, so this is going to be in the negative x direction. Positive x, positive y. Okay, so, and it's going in the negative x direction. The other is a 1,500 kilogram sedan. So it's coming from south to north. So it's 1,500 kilograms, and it is traveling at 23 meters per second. And that's in the positive y direction. So the two vehicles are traveling towards the intersection, and it says, part A, find the x and y components of the net momentum of this system. So what we're going to do is we're going to take this number and multiply it by that. So we'll get mass 1 times velocity 1. But since it's negative, since it's in the negative x direction, we're going to make it a negative 14. And that's going to be the momentum, the x component for the momentum. And then because the other one is in the y frame, that's going to be our y, and we'll just take its mass, 1,500, times its velocity, which is positive because it's in the positive y direction. And we punch that into a calculator, and our answer of this one is negative 35,000. And that's kilograms times meters per second. And this one comes out to be 34,500 kilograms meters per second. Okay, so now we have our x and y components of momentum. And that's the answer to part. So that is the answer to part A. Okay, and part B says, what are the magnitude and direction of the net momentum? So in order to find the magnitude and the net momentum, we're going to use this formula right here. Is equal to px squared y squared. So we'll plug in these numbers, these values for that. So we get the square root of negative 35,000 squared plus 34,500 squared. And if you punch that into a calculator, your answer is 49,145. And so that's going to be your magnitude. And now it wants to know the direction of the net momentum. And so since they're going in this direction, it's going to be about in that direction. So the way we find that is we just take the tangent. So we know that the tangent of theta is going to be equal to these two values, this value, your y value over your x component. So your y component is 34,500 over negative 35. And we can get rid of these zeros here because it's a fraction. We'll just reduce them. So we'll make it 3.45 over negative 3.50. And now we can just take the inverse tangent of that. So we'll take the inverse tangent of 3.45 over negative 3.50. punch that into a calculator, and that'll tell us the angle. That will actually tell us that angle. And that is 45.6. Make sure that's on. 45.6. And now we just need to add 90 for that. So it's just plus 90. And the angle is 134.6 degrees. So that's the angle of a net momentum. That's the value of the net momentum, and these are your x and y components.